In this video, we want to take what we have learned up to this point, try to bring it all together to help us sketch a polynomial. Let's look at part A. We want to determine the end behavior of the graph. We just need to look at the leading coefficient, which would be negative 2x cubed. This tells us everything we need to know. So let's first figure out the right end behavior. We can do that by looking at the coefficient, which is negative 2. The fact that 2 is negative means to the right the function ends downward. And then we can find the left end behavior by looking at the degree. The fact that my degree is odd means opposite. Therefore, it goes in the opposite direction than the right end of behavior. Therefore, it ends to the right, going up. Therefore, my right end behavior was down, and my left end behavior was up. Okay, now let's move to part B and let's find the Y-intercept. We know to find the Y-intercept, we need to let x be 0. So all we have to do is plug 0 in for x to my function. So my function, f of 0, if I plug in 0, you get 0 cubed plus 4 times 0 squared plus 30 times 0. Everything is 0, 0 plus 0 plus 0. Therefore, my y-intercept is 0. Okay, let's look at part C, where we want to find the zeros, which are also known as the x-intercepts. We know for x-intercepts, we always let the opposite equal 0, which is y. So if we replace f of x, which is y, with 0, we have 0 equals, and we are creating an equation that we're going to have to solve for x. Okay, so let's solve this for x. First, we want to look at it and see if there's anything we can factor out. And when we look at it, we definitely have a common x. But we also, if we look at the numbers, we have a common negative 2. So I'm going to bring out a negative 2x and see what we have. That leaves us x squared minus 2x minus 15. All right, and we still need to factor one more time. Let's factor. We have x and x, and we know that 15 is 5 times 3, so it factors. All right, so we have this factored. So for our x-intercepts, we just set each factor equal to 0, and that should give us our zeros or our x-intercepts. This would give us, let's see, for the first one, this would be x equals 0, 5, and negative 3. So these are my x-intercepts. So we also want to find the multiplicities of each 0. So let's look back. We had a 0 of x equals 0. So you can, if you remember, look back at its factor, and the power is the multiplicity. So x is raised to the first power. So it has a multiplicity of 1. When we get to 5, x minus 5 is raised to the first power, so 5 has a multiplicity also of 1. And the same goes for negative 3. If you look, that's raised to the first power. It's just an understood 1. So all of our zeros have multiplicity of 1. And the multiplicities are important because they tell us what happens at that 0. So remember, when multiplicity is an odd number, which in this case all 3 of our zeros have multiplicity 1, that tells us that if we had the point 0, that the graph passes through the point and it doesn't touch it. Okay, now let's bring everything together and try to sketch the graph. We want to first plot any points that we have, and we have found from part B that we have 0 as my y-intercept, which also happens to be an x-intercept. And then we also found our zeros to be 0, negative 3, right here, and then positive 5. 1, 2, 3, 4, 5, right here. Okay, so we know the graph has got to pass through these points. Let's look at the end behavior. We learned in part A that the left-end behavior is going up, so we can say that it ends going up, and the right-end behavior goes down. Now we just need to figure out what happens in between. So if we look at our zeros and their multiplicities, remember our multiplicities tell us what happens at that point, and all of these multiplicities are the number 1, which means the graph will pass through the 0. So when we get to, let's see, -3, as we are going down, it passes through the point. Now it's going to have to curve back up at some point. We don't know exactly where that is. Honestly, that's what you end up taking calculus for. But for right now, we're just doing just a basic sketch. So as we're coming back up and we get to 0, the multiplicity of 0 is 1. So we know that this is going to continue to pass through. And we've got to curve back down again to hit -5. And at -5, it passes through also. So here is a brief sketch, or just a basic sketch of the polynomial. Okay, we have one more example. I wanted to show you this one because if you notice the function given to you is already in factored form. So finding the left and right end behavior takes just a little bit of work. If we were to multiply this out, remember all we need is the leading term. And multiplying this out would take a long time. So what you can do is you can look at each factor and think of what the leading term would be with the highest degree. So when I look at x minus 1 squared, if I were to multiply that out, I have x squared as my highest degree. And then I look over at x plus 2 squared, and that's also x squared. And then x minus 3, you just have x to the first. So basically, you can just pick the largest term and degree of each factor, multiply those together. So if I multiplied these, I would get x squared times x to the first. If you remember, when you multiply those together, you add your terms, and that gives you x to the 5th. So my leading term for the whole polynomial is x to the 5th. This is very much a shortcut because it would take you forever to multiply the whole polynomial out. So this is exactly how I would do this. So let's find our end behavior. So the coefficient of x to the 5th is 1. Since it's a positive 1, we know the right end behavior goes up. And then if we look at the degree, which is 5, remember odd means opposite. Therefore, the left end behavior goes in the opposite direction, which is down. Okay, let's go to B and let's find the y-intercept. So remember the y-intercept, you let x equal 0, and you're going to plug 0 in everywhere you see x. So our function has f of x, which is y, equals, and I'm plugging in 0, 0 minus 1 squared times 0 plus 2 squared times 0 minus 3. So let's calculate what that is. We have -1 squared, right, which is just going to give us 1, times 2 squared, which is 4, and then times -3. It's all being multiplied. So we have 1 times 4 times -3 gives us -12. My y-intercept is -12. Let's determine the zeros and their multiplicities. This is nice because the function is already factored for us, which makes it easier. So remember, for our zeros, we have to set y equal to 0. And so let's set f of x is y, so we set it equal to 0 and solve. But since it's already factored, our zeros, we set each one equal to 0. We get x can be 1, -2, and 3. So let's see, when x equals 1, the multiplicity of 1 would be 2, right? Because x minus 1 is raised to the 2nd power, so the multiplicity is 2. Remember, when you have an even multiplicity, that means it touches. Let's see, try to write that as neatly as I can. And then for the 0, x equals -2, the multiplicity is 2 also, again. So multiplicity equals 2. So it touches. And then our last one, which is x equals 3, multiplicity is 1. Remember that says passes through. Alright, now let's sketch the graph. Let's plot the points that we have. We, of course, have our y-intercept to be negative 12. This is not to scale, obviously, but it'll do for what we need. And our zeros are negative 2, 1, and 3. Okay, let's look at our left and right in behavior. So our left in behavior goes down, and our right in behavior goes up. So as we sketch the graph from left to right, as we are approaching our x-intercept of negative 2, we see the multiplicity is 2, which means it just touches and turns back down towards our negative 12, which is our y-intercept, which makes sense because it's got to pass through negative 12. We head back up. As we approach 1, it's another 2 multiplicity, which means it turns back down again. And then when we get to 3, it passes through because our multiplicity was 1. So this is a basic sketch of the graph.